Hi everyone, in this video we look at a problem involving functions and it involves a quadratic function. So here it says in the problem you have a 600-meter roll of fencing and a large field. You want to make two paddocks by splitting a rectangular enclosure in half, and here we're going to assume that the person that's building this enclosure is going to use up all of the fencing. So in question number 8, it says express the area function in terms of the width. So anytime that we're solving a word problem in math, the first thing that we should always do is introduce variables. So let's let L and W represent the length and width in meters, and A represent the area in meters squared. So the next thing that I'm going to try to do is I'm going to try to just try to figure out where to go with this problem by seeing if I can relate the length and the width and kind of writing out what I know. Well, I know that I have two lengths of fencing. I have this length and this length. So I have two lengths of fencing. And I have 1, 2, 3 widths of fencing in order to make two rectangular paddocks. So I have 2L plus 3W. Now, since I'm using up all my fencing, 2L plus 3W has to add to 600. So I can now rewrite the length in terms of W. And I can rearrange this equation by subtracting 3W from both sides. I get that 2L is equal to 600 minus 3W. I can divide both sides by 2. And I get that L is equal to, if I divide 600 by 2, I get 300. If I divide negative 3 by 2, or negative 3W by 2, I get negative 3 over 2W. So now I've got the length in terms of the width. And remember that our goal in A was to express the area function in terms of the width. Now, I know that area is just equal to length times width. So my length, what this says is that my length in this problem can be expressed in terms of the width. My length, I can rewrite it as 300 minus 3 over 2W. So my area is equal to the length, which is 300 minus 3 over 2W times the width, which is just W. Let me actually here. Okay, wrong color. I have the length, which is this red guy, times W. So my area is equal to, my area as a function of W is equal to 300 minus 3 over 2W times W. And that's all that part A asked for. If you expand this, and some of you might have already noticed that that in this semi-factored form, that this is a quadratic function. If I expand this and I distribute W into the brackets, I get that my area is equal to negative 3 over 2W squared plus 300W. So this is going to help us out with the next problem, because if you look, this is a concave down parabola because we have an A coefficient that is negative. So the coefficient on the quadratic term is negative. So this parabola is going to open down. In the next part of the question, we're told to sketch the area versus the width. Okay, so let's try to figure out a couple things. So notice that if to sketch a parabola, we definitely need to know the vertex. Another thing that helps is to know where the zeros of a function are. So since this parabola opens downward, and it's we don't have this written in vertex form, but we know that from factored form, since I can factor this quadratic expression, that the area is going to have two zeros. So to figure out where the zeros are, I can let A of W be equal to 0. So let's let A of W be equal to 0. And that's equal to W times 300 minus 3 over 2w. Now right now this is written in kind of factored form. It's I can make this look a little bit nicer if I common factor out negative 3 over 2. So if I divide both of these terms by negative 3 over 2, I can make this look a little bit nicer. So let's common factor out negative 3 over 2, and I get negative 3 over 2w times negative 3 over 2w divided by negative 3 over 2 is just w. 300 divided by negative 3 over 2 is the same thing as 300 divided by negative 3 times 2. So 300 divided by negative 3 is 100 times 2 is 200. And if you're not sure how I got that, well, 300 divided by negative 3 over 2 is equal to 300 times times negative 2 over 3. Because division by a fraction is the same thing as multiplication by its reciprocal. So if you do 300 times negative 2 over 3, you get 300 divided by 3, which is 100. 100 times negative 2 is negative 200. So hopefully that helps you understand the arithmetic of that step. So now that I've gotten this written in factored form, I can solve for the zeros by saying what values of w make this equation true. What values of w make this statement true? So notice that if w is equal to 0, if w is equal to 0, then the left side of this equation is 0 and the right side is 0, because I'd have negative 3 over 2 times 0 times some other number, which is 0. Oh, sorry guys, this should be 200 here actually. I wrote 100, it should be 200. Sorry about that. The other solution to this equation is if w is equal to 200. If w is equal to 200, I have negative 3 over 2 times 200 times 200 minus 200, which is 0. So any number times 0 just gives you 0. So another solution that makes the left side equal to the right side is when w is equal to 200. So my area is going to be 0 when w is 100 or w is 200. So the next step, well, let's see what that produces. Well, I know that on my graph, my parabola, I'm going to have a point here at 0, 0, and I'm going to have another point at w is equal to 200. So this is 200, 0. Okay. So then I've got to figure out where my vertex is, and since I'm just drawing a sketch of this parabola, I'm not actually going to draw a grid and plot 5 points. I'm just going to plot the zeros and the vertex, and that's a sketch. If I were to ask you to graph the area versus width and provide you with a grid, then I would expect you to hopefully graph 5 points on the parabola, and one must include the vertex. So to figure out the vertex, we remember that a property of parabolas, and that property is that the vertex is always halfway between these zeros. So that's the x value of the vertex, sorry. And there's a vertical line that I can draw through the vertex, and that line essentially cuts the parabola in half. That's called the axis of symmetry, or the vertical axis of symmetry. So that means that if I find a value that's halfway between 0 and 200, then that's the x value of my vertex. And here we're actually not dealing with y and x. We're actually dealing with the area. So we're dealing with the area and the width. So instead of using variables x and y, we're going to use variables w and a. So if you're not sure how to find a number between that's exactly halfway between two numbers, an easy way to do that is to add them up and divide by 2. So 0 plus 200 divided by 2 gives us a number that's exactly halfway between 0 and 200, which, as you can probably guess, is already, or which you can probably guess already, is 100. So my vertex is, the coordinate of my vertex is 100, comma, and some value for a. Now, to get the a value of my vertex, I can just plug in 100 into my function. So a of 100 is equal to 100 times 300 minus 3 over 2 times 100. And if you do that on your calculator, you should find that a of 100 is equal to 15,000. So this point is 100, comma, 15,000. So my last step is just to draw a smooth curve through these 3 points. And try your best to make it nice, smooth, and symmetrical. Let me retry that. So that's essentially what the sketch of the area versus width would look like. Now let's use this, the graph that or the sketch that I've just drawn, to determine what the domain and range are. So for the domain, I have that the domain is the set of w, all w values that are in the real numbers, such that w has to be strictly greater than 0. Because if w is equal to 0, that would have meant that I would have used all of the fencing for the length, and I would just have a line. And a line is not a rectangle, or a line is technically a rectangle that's just infinitely thin. So w has to be greater than 0. W also has to be less than 200, because if w is 200, that would mean that I would have used 3 widths of fencing that are 200 in length, and that would have meant that I would have used all of the fencing for the width. And again, that would have just been a one line of fencing, or a rectangle that's infinitely thin and has 0 area. So the way to draw that this point here, w is equal to 0, is not included, is notice that I included a hollow circle. That means that the point 0, 0 is not included on my graph. And it's the same thing with 200, 0. I drew a hollow circle. That denotes that 200, 0 is not on my graph. So for my range of values, I have that, well, my area is an element of the real numbers, or we have the set of all a in the real numbers, such that a has to be strictly greater than 0, and a has to be less than this maximum value here, or less than or equal to this maximum value, which is 15,000. So we have our domain and we have our range, and that concludes this lesson, and we'll see you in the next video.